Confidence intervals. No questions. Yeah? Perfect. All right. So if we don't have any questions, we'll go ahead and move on. Any non-homework questions in general? So we're still planning for exam 4 next Thursday. I think we're on pace for that. And then do chapters 9 and 10. So we're going to go into 10. We're going to start 10 today.
What chapters?
9 and 10.
9 and 10.
Yeah, and the homeworks for both of those are out. And they're due on next Thursday. So, all right. Okay. So, yeah, because we actually, yesterday, with the confidence interval stuff, that wrapped up everything out of chapter 9 that you guys should need, I think, with the T intervals. All right. So then today, we are going to move on. I do have your exams, so if you, I put the scores, I did post the scores on my stat lab, your grade book, so you can see those. But I'm just going to have you guys grab those on your way out today. So we can go ahead and get started on this stuff, on our material. All right. So yesterday, or in chapter 9, we were talking all about like point estimates. So the idea was you go out, you take a sample, and you get a sample mean, or you get a sample proportion. Yeah? And the problem, though, is that what? What's the problem with that estimate, since you took a sample?
No.
Yeah, I mean, there's some error to it, right? And so it's probably actually overestimating or underestimating the truth a little bit. So we form confidence intervals. And so that's like point estimation. We're going in kind of blind, saying, I don't know anything about this value, so I'm going to take a sample and see if I can get it. In chapter 10, we're going to answer or tackle a different problem. We're going to talk about, rather than going in blind, we're going to be talking about testing claims. So testing claims that someone or something is made, or some assumptions that are being made. All right? So to get us started, I'll give you an example. All right, so I looked this up yesterday. And so if you look at Toyota, they claim that their 2016 Camry Hybrid gets 42 miles per gallon in the city. And I had to reread it at first, actually, because I guess in hybrids, their city mileage is better than their highway mileage. I guess because the engine's not running the whole time. Yeah, it's sort of the opposite of what you'd think. Yeah, so the city mileage is actually higher, which kind of surprised me. But that shows how much I know about hybrid cars. But okay, now the question is, let's suppose, so they're coming out and they're claiming this. Now they probably have a really good reason to claim this. I'm sure there's a pretty rigorous way that the EPA actually tests these claims. But let's say that this claim hasn't been tested. They just built the car and they're saying, my car gets 42 miles per gallon in the city. Well, what if you don't necessarily believe them, or you want to confirm their claim? How would you go about testing that claim? Right. So how would you test this claim? So what would you do if you could? Right. What would you do to test this claim if you were given, access to Toyota? How would you test that?
Test cars.
Yeah. So you would go in and you'd randomly select some cars, and then what would you do with them?
Show me the car. No,
No, we want to do it ourselves, right?
Drive it around and then record how many miles.
Yeah, so you drive it around the city, don't go on the highway. Drive it around town and record how many miles per gallon it gets, and then maybe go do another car, right? And you go out and you get another car and you test it, get its average miles per gallon, and blah, 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 right? So you're going out, you got a mile per gallon for a whole bunch of cars, and then what would you do with that? With all those different cars, miles per gallons, what would you probably do?
Average.
Yeah, so you'd maybe take a sample, I don't know, size in, however many you think you could reasonably actually test. I don't know. Probably depends on how many they're willing to give you. Okay, but you take a sample, and then you probably maybe calculate, say, the sample mean of those cars, and then what would you do? So they're claiming it's 42 miles per gallon. you sampled a bunch of cars and calculated an average mile per gallon. What are you going to do? How are you going to decide whether you believe them or not? Yeah, you can just compare it to 42. You say, hey, I drove all these cars around and they averaged 42.1 miles per gallon. Hey, okay, sounds pretty reasonable. Or I drove all these cars around and I only got 30 miles per gallon. So what are you thinking then? Yeah, you're thinking maybe their claim isn't actually true. Or maybe you're just a really bad driver. I don't know. Okay, but maybe their claims aren't true. So this is what we want to do. We want to talk about how do you test a claim using a sample about means or proportions. And this general process, we call this hypothesis testing. Okay. And typically in hypothesis testing, we say there's two types of hypothesis. There's first what we call a null hypothesis. And in statistics, we denote that with a capital H with a little subscript of a 0, so H0. So that's our null hypothesis. And this is typically the claim or the assumption. So there's some claim being made about, say, the mean, or there's some claim being made about a percentage or a proportion. That's what we call our null hypothesis. But typically, we often have some sort of potentially alternative hypothesis. Which we call H1. So some books might call that HA. Your book uses the H1 notation. And this is what you could potentially be true. So I'll just say what you believe could otherwise be true. Yeah. So someone makes a claim, but we're all statisticians now, so we've learned to be a bit skeptical, and we say, I don't know, I think I want to test that before I just take your word for it. And your alternative hypothesis may be, maybe you think Camrys get less miles per gallon. Maybe you think Camrys get more miles per gallon. All right. So typically the null hypothesis and the alternative hypothesis, we state them in terms of the parameters that we're talking about. So remember, the parameters here, if we're talking about a proportion, right, we use a little p. And if we're talking about a mean, that means we're trying to estimate or say something about a true mean mu. So typically the format of a hypothesis test takes on this. The null hypothesis would be of the form, say that the mean equals some claim. So mu equals mu0. This is right here. This is the claimed mean, or the assumed mean. We call it mu naught or mu0. All right. And your alternative, though, can take on a few different forms. So, like I said, it's possible you might think the truth might be bigger than what they're saying, or you might think the truth is less than what they're claiming, or potentially the third scenario is you might not really know whether it's more or less, but you definitely want to know if it's not what they're claiming. And so you can just have a general not equal to alternative. So there's three choices for your alternatives in a hypothesis test. So they make a claim. Your alternative is that it's either more or less, or potentially like I'm not sure, but I just think it's not equal to that. Those are your three potential alternatives. All right? So normally we set them up in, this is what we would call like a formal hypothesis test. We would format it like this. The reason we're going to format it like this is because it's going to help us actually decide how to make a decision using Actually, it ends up we're going to go back to the central limit theorem and use it again just like we did for our confidence intervals. So, all right, so let's look at, for example, like the Toyota claim, right? So the Toyota claim of, what was it, 42 miles per gallon? Right? So Toyota claim is 42 miles per gallon. Maybe you think the truth is less than that. So maybe you bought a 2016 Toyota Camry hybrid and you're not realizing the mileage, so you think the truth is less. So in that case, what would be the null hypothesis? And what would be our alternative? So the null hypothesis is always parameter equals something. So it's always equals. Our alternative is where we have where we're going to pick some other option. So what is the null hypothesis here? What's the claim being made?
42.
So we would say the null hypothesis is that the mean is 42 miles per gallon. The alternative hypothesis, in this case, what do we think is alternately true? Yeah. So we would choose a less than alternative. Right? This is how we set it up. So again, the alternative is always equal, and then the null is always equal, and then the alternative is one of those three choices. Okay. All right.
So,
Yeah, go ahead.
so H1 is either less than, greater than, or
Not equal. Not equal. Not equal. Yeah. Okay, so let's think of another example that we could use. So we also talked about proportions. All right, so let's say that, let's say historically, our pass rates in Math 84 were 65%. So are we talking about a proportion or a mean now? A proportion, because this is a percentage. Okay. So historically, pass rates in Math 84 were 65%. So maybe you develop a new program and you want to see if it has any effect. I think it's effects. You can affect something and you can have an effect. I don't remember. It's an A, I think. Doesn't matter. Okay, so new programs implemented to see if it affects pass rates. All right. So here, the other thing about the null hypothesis is sometimes it's not always something that is being claimed specifically by someone, but it could also, the idea of the null hypothesis means it's sort of like the status quo, right? So you go out and you implement this new program, and it's possible that what could happen? It's possible that you put in all this work and you implement a new program, and what happens? Yeah, I mean it could tank. I mean it could actually it could be worse. It could make your results even worse. Maybe you have lower pass rates, or what else could happen? You get better, or what? Maybe it stays exactly the same. So in a hypothesis test, we always assume sort of like the status quo, or what is currently being claimed, or what currently exists. So our null hypothesis here. Now notice we're going to use a p because we're talking about a proportion, and assuming that our thing has absolutely zero effect, what would the true proportion be in our new program? Yeah, we would assume it would just stick with the status quo basically, right? 65%. So we're just going to start from that base and say, let's just assume that it has no effect, and let's see if we can prove that it actually has some effect. Now in this case, did we really specify whether we think it's going to make it better or worse? No. So what kind of alternative would probably apply here? Yeah. This is one of those situations where going into the problem, you have no reason to believe that the truth might be bigger or smaller. All you're interested in seeing is it different than that? Because I want to know if it's less, that's important. But I also want to know if it's more, that's also important. So I don't make the assumption ahead of time. I just say not equal to alternative. All right? Okay, so one of the most familiar places that we actually have, well, hopefully we don't all have too much experience with it, but we understand it, is in, say, like a U.S. court of law. Right? So like in a trial. So that's why I say hopefully we don't have tons of experience. But you don't know. So in a U.S. court of law, actually, they operate under sort of a hypothesis test where you come, well, supposedly, or the way it's supposed to be, is that if you're charged with a crime and you go to trial, what is supposedly the null hypothesis or the null assumption about you? Right. So what they have here is you have a null hypothesis of not guilty, right? But then, of course, what's potentially alternatively true? Yeah, you're guilty, right? So a trial for a crime is actually like a hypothesis test, where you're walking into with the assumption or sort of the status quo of not guilty, and there's it's potential that based on evidence you may eventually change that decision. But you want to give, the idea is that the null hypothesis gets the upfront, it's like an upfront assumption, it gets more weight. It's saying we want to say before anything that we're just going to assume the null hypothesis is true unless we can prove otherwise. And that's the same thing with like the cars. We're going to take Toyota's word for it until we can prove otherwise. All right? We're going to assume our program has no effect until we can prove otherwise. Now, the thing about hypothesis tests, though, and it happens in trials as well, is that you can only make two choices in a hypothesis test. Right? If you go to court and you're on a jury for a trial, there's only two choices you can make, right? What are the choices you can, well, I mean feasibly, besides a mistrial or a hung jury. But if you're going to make a decision, what's the only two decisions that can be made?
Guilty or not guilty?
Guilty or not guilty. All right? But this kind of creates some problems. So I'm going to draw you a little table here. So you get to make one of two decisions when you do a hypothesis test. The first thing you could do is you could take a sample and get evidence or whatever, and you could say, nope, I don't believe you. I'm going to reject your null hypothesis. That's one possible decision. You say, nope, I saw evidence. I drove a whole bunch of Camrys, and they did not get that much miles per gallon. I do not believe you. I reject your null hypothesis. The other possibility, though, is you can say, well, maybe you don't reject. Right? So basically, you only have two choices. You can accept their claim or you can reject it, essentially. But the problem is that just because you make a decision doesn't mean that was the truth. Because in reality, either their claim is true or their claim is false. Okay. So you go in to, say, a court, or you go into a hypothesis test. You do whatever you have to do, take your sample, and let's say you reject the null hypothesis, and in reality it was false. Did you make a good decision? You rejected it, and it was false.
Yeah.
That's a good choice, right? Because you said, I don't believe you, and it turns out you shouldn't because the null hypothesis wasn't true. So right here, that's a good choice, right? Good choice. You did the right thing. The other possibility is you fail to reject their claim when their claim was true. Is that a good thing or a bad thing? You fail to reject it and it was true. Good thing or bad thing?
Good.
Good, right? You see, you failed to reject it saying basically, okay, I'll take your word for it. And it turns out you should have because they were telling the truth. So that's also a good choice. Yeah? But what about these two boxes? These are bad decisions. Because here, you're rejecting their claim when it turns out they were telling the truth. This is a problem. You made the wrong choice. And this is a type of error. We call this a type 1 error. Type 1 error in a hypothesis test. So you basically are saying the claim is false. You're going to call Toyota a liar, right? When in fact, hey, they were actually telling the truth. You know? It's not very fair. But the other problem is if you fail to reject it when they were actually when it was actually false, that's also a bad decision. Because you didn't reject their claim when in fact their claim wasn't true to begin with. So if we call this a type 1 error, what do you think we call this? Type 2 error? Yeah. Good guess. All right. So it's not perfect, right? A decision in a hypothesis test, there's always some chance you're going to make an error. Just like with a confidence interval, right? There's always some chance your confidence interval doesn't actually even contain the truth. And it's the same way in a hypothesis test. So, like if we go back to the examples, let's go back to the examples we looked at. So say, let's go back to the Toyota claim. Let's go back to the Toyota claim where they were claiming it's 42, H1, and you think the truth is less than 42, right? So in this case, what would be a type 1 error in this case? How do you make a type 1 error if this is your test? What are you going to say and what's actually true if you make a type 1 error?
If you say it's less than 42 and it's actually 42 or
Yeah.
above.
Yeah. So you're going to conclude that the mean is less than, whoa, this computer, man. That's gone back. Less than 42. When in fact, it is 42 miles per gallon. So essentially, you're going to be coming back and saying, hey, I don't believe you. It looks like your cars aren't actually getting 42 miles per gallon. And in reality, they actually are. Now, how could something like this happen? How could it happen that you end up rejecting their claim even though they're actually telling the truth? So think about how you're testing this claim.
Human error.
So it could be human error, just like maybe you made some miscalculations or something. What's some other possibilities? Remember, we're only taking a random sample of a few Toyotas. What could be true about those few Toyotas we ended up looking at?
High miles.
Well, let's say we get them all new. Let's say you get all brand new ones, right? Because we're talking about 2016 Toyota Camrys. Let's say you get them all brand new off the factory line.
Do you give target defects?
Yeah, so you might just end up with a few that aren't that great, right? Because every single car that comes off the lot is not going to perform exactly the same, right? They're just talking about an average of 42 miles per gallon throughout their entire production line. But some of them are going to come out doing a little better, and some of them come out doing a little worse. And maybe you just happen to randomly sample 15 Camrys that were on the lower end, right? So you get a really low sample mean, and you go back to them and say, I don't believe you, but in reality, hey, you just got a bad sample. So one way we can avoid that, would be a bigger sample size. But it could happen. Now, what's the type 2 error here, though? What's the type 2? What are you gonna conclude in a type 2 error?
You're going to say it's true when in reality it's false.
Yeah. So you basically conclude, as far as you know, that the mean is 42 miles per gallon, when in reality, what's true? So you're going to actually come to the conclusion and say, okay, I drove some Camrys, looks like Toyota's telling the truth, and in fact, actually, they weren't. Their claim wasn't true at all. Just based on your sample, you're going to take their word for it. Okay. Now, is one of these errors better than the other? I mean, would you rather commit one over the other?
Yes.
No? Yes?
An error is an error.
But what if you can only pick one? What if you can only pick one error to not commit or something?
Type 2, I guess.
Would you rather commit a type 2 or a type 1?
Commit a type 1.
You'd rather commit a type 1 error.
Yes.
So you'd rather go back and tell Toyota, you want to go call Toyota liars when they're telling the truth. You'd rather do that. Yeah? Okay. So you guys like getting sued? Is that what you're you guys like having lawsuits brought against you? That's okay. All right. What about type 2? But what's the problem with type 2? They get away with it, right? So I mean, it probably depends on who you are, I guess, right? I mean, if you're maybe like the EPA who actually sets mile per gallon ratings, you might not care that much about getting sued. They get sued like all the time, right? But they really do want to make sure that they're presenting accurate information to consumers or something, right? So it depends. So we're going to get back to this about like which error you'd rather commit. It actually has a connection to our confidence level. So, but I want to go over a couple more here. So let's go through the other scenarios we talked about. So like with the Math 84 program, right? The null hypothesis was that the had no change. It kept your pass rates at 65%, and the alternative was that it's going to change something, right? So if this is what you set out to test, what would happen if you made a type 1 error? What would a type 1 error be? What would you conclude? Type 1 means you do what when what's true? Go back to your little table.
You lie, say it's not when it is.
Yeah, you reject when you shouldn't. So in a type 1 error, you're going to conclude that the program doesn't have a 65% pass rate when it actually does. So what could be a potential practical problem with making a type 1 error here? Because how is this going to drive your decision? So let's say you go take a test and you see some results that say, hey, this program doesn't actually have a 65% pass rate. Maybe you get a result and it looks like maybe it has better pass rates, but in fact it doesn't change anything at all. Or what if it has worse pass rates when in fact it doesn't change anything, or something like that? What's going to happen here? What kind of bad decisions are you going to make based on that error?
You're going to not implement the program that's actually better.
Well, in this case, in the type 1, it's saying that the null hypothesis is true. So this is actually saying the program is ineffective in the sense that it doesn't change your pass rates at all, when in reality it has. So this one could have, both implications though, right? You might toss it out. You might toss it out because it doesn't look effective, but when in fact, actually, maybe it was effective. Something like that. Or on the flip side, you might toss it out. Maybe it was way cheaper to do it this way, and so you toss it out when in fact you could have just left it and saved yourself a whole bunch of money, right? But what's the type 2 error here? What's the type 2 error?
You say it's good to go and it's not.
Yeah, so you're gonna conclude that the program has an effect. So that it's not 65%. Is that right? No effect. Sorry, type 2. You're going to conclude that it has no effect, when in fact what is true? Yeah. So you're going to say, hey, this program you're going to conclude that it has absolutely no effect when in fact it really does. Okay, and this also has problems because then you're going to say, okay, well, looks like it didn't work, toss it out, whatever. And so you don't really want to make either, but one could be better than the other, right? This is especially type 1 and type 2 errors are especially a big deal if you think about the example of our justice system, right? So if your null hypothesis when you walk into a courtroom is innocent, and the alternative hypothesis is, say, guilty, then how does a jury make a type 1 error in a case? Yeah, so basically, what do? You convict an innocent person? What about a type 2 error, though? What's a type 2 error in a court of law? Yeah, so exactly. So you basically, a guilty person gets away with a crime, right? So you don't convict a guilty person. Which one's worse?
Because it depends on the crime.
Oof. Sucks when the stakes are high, right? Which one's worse?
I feel like the top one's worse.
You think convicting an innocent person is worse?
Well, if you let the guilty person go, he's probably gonna go commit another crime and therefore get caught eventually. But if you convict an innocent person, then you've wasted that person's life.
But what if the crime they committed was like serial killing? Now you're gonna let them off and just like go out and get caught later after they killed 4 more people?
That's fine.
I mean, if it was, I think.
Yeah, I think most people I think do lean towards saying a type 1 is worse because you don't want to convict an innocent person. But I think it depends on the crime, probably, right? Maybe.
No. Yes.
No, you say no, never.
If it's a child rapist, I don't know.
Yeah, I mean it really depends on the crime. I don't know. I don't know. That's a tough choice.
If it's a child rapist or the person that you convicted that's innocent was being convicted of rape.
I mean, on that point, that's pretty bad, right? I mean, if it's a really high stake, I mean, if it's a bad crime, I mean, both of these suck really bad. You really don't want to do either, right? But can you actually reduce either of these error rates to 0? Is it even possible? It's not really even possible. No matter how well you structure a court, or no matter how well you design a sample, there's always a risk that you're going to make a mistake, right? There's always a chance, and it happens. So way back when we were talking about our confidence intervals, right? So think back to the idea of, say, like confidence levels and alpha levels that we talked about earlier this week, right? And we talked about some common confidence levels, like we talked about sometimes maybe 90%, which would be 10% alpha level, 95% confidence, which would be a 5% alpha level, or maybe 99% confidence, and the alpha would be maybe a 1% level or something like that. So my question then was, if our goal is to estimate things, why don't we always just pick 99% confidence? Why don't we just always try to be really, really confident in our results and take a really small alpha level? Why not? So one thing it does is what? In the interval case, what happens to as you change the confidence level? What do you have to do to have more confidence? What do you have to do to your interval? Yeah, you got to expand. You got to make it wider. So you lose some sort of precision, I guess, in a way. So there are some downsides to it, but you can overcome that with sample size, right? Now it turns out, though, actually, there is a good way to set this in advance, and the reason is that the way we're going to set up our hypothesis test is that alpha level, the way that it's structured is going to be the bound on the probability of a type 1 error. So when you set an alpha level in a hypothesis test, what you're basically saying is, this is how often I'm willing to make a type 1 error. You know, I only want to make a type 1 error 1% of the time, or I'm willing to make a type 1 error 5% of the time, or 10% of the time. Right? So, what do you think you should always set your alpha level at? If it bounds your type 1 error rate, then what would you want to set your type 1 error rate? I mean, you can't set it to 0. That's not really feasible.
I mean, I guess I would always want it as low as possible.
So you'd think, yeah, right? Why not just always set it really low? Let's just always set our alpha level to 1% or 0.5%, because I don't like making errors, right? I don't like making errors, so let's set my alpha level low. But there's a problem with that strategy. And the problem is, no, it's a great guess. And it's what I think it's the intuitive answer, is let's always set it low. But the problem is think back to our chart. You don't necessarily have to redraw it. So reject, fail to reject, right? H naught's true, H naught's false, right? Well, you know, here's your type 1 error, and here's your type 2 error. Okay? If you have a fixed amount of data, or like you're in a courtroom and you have a fixed amount of evidence, right? You can't go sample more people, you can't like produce more evidence, only a certain amount exists. If you really don't want to make a type 1 error, that means you're going to have to reject the null hypothesis less often. But if you reject the null hypothesis less often, you only have two choices, so what are you going to do? So if you're in this column less often, where does that force you into? Well, it means it forces you into this column, right? So if you only have two choices, and you're intentionally saying, I'm going to make this choice less often because I don't want a type 1 error, well then, now you got to do this more often. Well, okay, so if you say, I don't want to be here as often, I'd rather be here, well, now what have you done to your type 2 error? What's going to happen to your type 2 error? It's going to go up. That's the problem, is there's a trade-off. So what you see is that as you drive down that probability of a type 1, then that probability of a type 2 goes up. So there's a trade-off. All right. There's people in our ceiling. Apparently. Yeah. All right. So this is ultimately how you make a decision, and it's vice versa too. So if you let your probability of type 1 go up, that'll drive down your probability of type 2. So they work against each other. So this is why sometimes you would want to set alpha levels that are not necessarily really low. So let's go back to, let's say, the Toyota example. Where we said what? That a type 1 error was that you basically call them liars. I'm paraphrasing here, right? When they're not. And a type 2 we decided is basically they get away with lying. That's pretty brief. Doesn't really encapsulate the whole situation, but that's basically what we said, right? Now, if you're, say, the Environmental Protection Agency, the EPA, who sets these ratings, which one of these would you rather commit, and which one of these would you not want to commit? So let's say you're the EPA. They may decide which one's more acceptable.
Well, the top one's gonna get them sued less.
Calling them liars.
Or, I mean, the bottom one's gonna get them
The
sued.
bottom one's gonna get them sued less, probably true. But then what's gonna happen?
You have more liars in the world.
Yeah, you're gonna end up with. I mean, as a regulatory body, would you rather err on the side of getting sued and being sure they're actually producing the cars at the level they say they are, or would you rather err on the side of I don't really want to get sued, so you can make your cars however you want?
If I was in charge of the EPA, getting sued more would mean I was doing my job better.
Yeah. So.
In my opinion.
Yeah, I think it depends, but I think from a regulatory standpoint, as a regulatory standpoint, I think someone like the EPA, they're going to be really concerned with making sure people are actually doing what they're saying they're doing.
Right.
And so you would say, yeah, it's part of the job. Sometimes you're going to make a mistake and say you're not meeting your standards, and they are, and they're going to sue you or whatever. But it happens. So the EPA might decide that actually in this case, a type 2 is worse, right? They think a type 2 is the worst. They really don't want to do that. Well, if you want to drive down your probability of a type 2 error, whoops, I don't want that. So if you want to drive that down, what do you need to do what do you need to accept with your type 1?
Higher error there.
Oh, yeah. And so you're saying, look, I really don't want to make a type 2 error because I do not want car agencies out there reporting mileage that they're not actually achieving. Don't want to make the type 2 error, so I just have to be willing to make a type 1 error more often. But what is that? What bounds our type 1 error? That's our alpha level. So this is a situation where because they really don't want type 2, they're going to allow the error rate, the type 1 error rate to rise. So they might pick a higher alpha level. And this is one of those cases where maybe you pick a higher alpha rate, like 10%. You say, I'm willing to make a type 1 error 10% of the time because that's a better scenario than the opposite. Right? Yeah. So let that type 1 error go up and just recognize that 10% of the time you're going to decide a company's not meeting their standards when they actually are. But that's a lot easier to undo than letting them send out a bunch of stuff that's not actually doing what they say it does. This would be especially interesting. Think about from like an EPA standpoint. What if you're talking about, say, what if you're talking about standards of like drinking water, right? If you're talking about what if they were trying to do a test, right, to determine if say like contaminants in the water exceed regulations. Right? So they have some water they need to go test, and they need to decide, hey, is this water actually as clean as you say it is? As a null hypothesis, you're gonna walk in there and assume that the mean meets the regulation. But it's possible that you could take a sample and find out that the mean actually exceeds, oops, I don't know why I said meets there. That word is not necessary. Just say equals. So the mean equals regulation. But it's possible that it exceeds regulations, right? And if you think about the type 1 versus the type 2 here, which one's worse? So if you commit a type 1 error in this scenario, what are you going to do? What's going to be the conclusion? So in a type 1 error, you're going to reject the null, so you're going to say what? You're going to say, it looks like you're exceeding regulations when you're not. right? You're going to claim that the water is basically, I mean, this is paraphrasing. You're going to claim the water is dirty when it's clean. You're going to run some samples and you'll be like, whoa, your water is not meeting expectations. We need to do something here. But the type 2 error would be what? Yeah, you're going to claim the water's clean when in fact it's actually dirty. Which one's worse? Yeah, most people would agree. Well, I don't know. So you're okay with a type 1 error?
Yeah.
I mean, which one's worse? You think a type 1 is worse or better?
Better.
Yeah, so you're saying a type 1 is more acceptable? I would way rather say this water's dirty when it was actually clean. Because when you make, if you're like a regulatory agent or something, if you say the water's dirty and it's actually not, what can you always do? You can always go back and do what? Do more samples. Sample it again. Make sure you didn't make a mistake, right? But if you talk about a type 2 error and you say, hey, water's all good, it's all clean, and they're actually pushing dirty water through the pipes, what happens? It's not like you're going to go, you don't have any reason to go back, right, and retest it anytime soon. And so they would probably lean towards a type 2 error here. Of course, if you want your type 2 error low, then you're going to have to allow your type 2 error high to rise a little, and so you pick a higher alpha level. Yeah? Make sense? Okay, so this is why we actually pick our alpha levels sometimes higher, even though it seems like intuitively you'd always want them lower, and the reason is because we want to really not make those type 2 errors. Yeah? Now, okay, so that's all cool. We know how to set up a hypothesis test. We know how to figure out what alpha level we want to set. Now the question is, how do you actually decide when to reject? Right? How do you actually decide? When do you make that switch from believing them to not believing them? You know, if you're on a jury, this person's supposed to be innocent, and you hear a little evidence that suggests they might be guilty, and you hear a little evidence that a little more evidence and a little more evidence, and eventually you hear enough evidence that you change your mind, or maybe you don't. Okay? So think back to that Toyota car, okay? So they say their car is getting 42 miles per gallon. You think it's getting less. Okay. So you go out and you take a sample. So how many cars do you think, let's say I want you to test this claim and I give you like a week or something. How many Toyota Camrys do you realistically think that you could sample and drive around in a week or a weekend or, you know, over the course of 4 or 5 days? What do you think?
30.
Okay, maybe 30? Yeah?
2 days.
A couple days. I don't know. I'll give you a week. Okay. I say, Brittany, come back to me next Thursday and tell me if you believe Toyota. Here's a bunch of cars. So maybe 30. Yeah. So you go out, and let's say that you sample 30 vehicles, right? And what if you drive those vehicles around, and you get a sample mean of 41.6 miles per gallon? You believe their claim, or do you not believe their claim?
Yeah.
You believe them? But it's less than 42, though.
Round up.
Oh, you're going to round.
Yeah.
Okay. Okay. Well, what if you go, okay, so here you're not going to reject, right? So you're saying, I'll just accept their claim, right? Because it was a little lower, but, you know, whatever, I only drove 30 cars. What if the sample mean came back to 41.2 miles per gallon?
Rejected.
Well, you only looked at 30 cars, though. Is that still low enough? Is that too low? How many here, if you drove 30 cars and you had an average of 41.2, you're willing to go back and to Toyota and risk litigation and say, you are liars? How many are willing to do that?
I don't know if I'd say quite like more polite.
Oh, okay. Okay. So do you believe them or not believe them right now? You still gonna take their word, or are you gonna reject them? Who here would actually accept it and just say, yeah, I don't know, that seems okay? So some people would. Some people are saying they're getting close to willing to reject. Yeah. So we're getting some mixed messages. I don't know. I can't decide. I don't think I personally would be willing to do this at this point. You know. But what happens if you go out and the sample mean is 40? You sample 30 cars and the sample mean is 40. Are you willing to go back and say, I don't believe it?
Yeah.
Maybe at this point, yeah. At this,
Even if they offer me a bribe.
that's right. So now, yeah, use it as leverage or something, right? But at some point so the point though is that it's like eventually you're willing to make the cut, right? So somewhere along this line, there was a cutoff where we said, if you go beyond that point, I will no longer believe you. Now, do you think it's a good idea to just arbitrarily decide what that cutoff is, though? Probably not, right? So just like we don't want to like arbitrarily choose confidence interval widths, right? We ended up using like the normal distribution and stuff to justify that. We don't want to like just arbitrarily make those cutoffs and say, I don't know, with 30 cars, I think once you go under 40.5, you're liars. Okay, let's go. Sample time, right? You want to have some justification for making that cutoff, right? So the solution is we use the central limit theorem. And you thought we would never revisit that, right? Too bad.
No, I figured it would come back.
You figured it would come back. That was a good intuition. Yeah. So we're going to use the central limit theorem. So let's think about. I'm going to do the proportion one first because it makes because the proportion. Remember, we were actually able to use z-scores with the interval, so it's a little easier to deal with. Go ahead.
I have a question.
Yeah.
So how do you know what to set the alpha level to?
Well, that's what. So it depends. I mean, the answer is it depends, and it depends on what's worse, a type 1 versus type 2. Now, typically speaking, we don't pick alpha levels more than 10%. Typically, there'll usually be the most common are like 1%, 5%, and 10%. We rarely go above that.
So is there a certain alpha level that corresponds with like type 1 error?
Well, the alpha level is your type 1 error rate. So, right here, your alpha level that's exactly what your alpha level is. Your alpha level is the bound on your type 1 error rate. But how you set it is based on what type of error you are more or less willing to make. So if you really don't want to make type 1 errors, then boom, go down to 1%. Type 1 errors are bad, alpha 1%. If you really don't want to make type 2 errors are really bad, bump that alpha level up to 10% so you don't make type 2 errors as often. Okay? Yeah. Yeah, maybe I should. Where was that slide here? I don't remember that one is. Here, I'll just put a summary there. We're about to run out of time anyways. But it's worth summarizing though. Here's the idea. So if you decide type 1 error is worse, pick a low alpha. So maybe like 1%. Sometimes we go even lower than that. Okay. Sometimes you might even go to like 0.5% or something like that. Especially when you're talking about when they do tests for, say, like serious diseases. So like if you're taking an HIV test, right? Then they what you really don't want to do is tell someone they don't have HIV when they do, right? So what they do is they say, I really don't want to do that, and so they set it they make sure that the error errs on the side of flagging people who don't have HIV. Because if you flag them, and then you can always bring them back in and test them a second or third or fourth time, but you really don't want want someone who has HIV out there not knowing it. Okay? So you decide up front. So if a type 1 is way worse, you say lower that alpha level, use a 1% maybe. But on the flip side, if you decide that type 2 error is worse, you say, okay, I really don't want to make a type 2. That is bad news. You know, I don't want people drinking dirty water. So now let the type 1 be a little higher and pick a high alpha level. And when we say high, again, you know, we never really let alpha go above maybe 10%. If you're in a situation where you don't think that it really matters, you know, maybe they're both not that great, but the stakes aren't that high, then maybe our standard alpha level that we typically use is about a 5%. So 5% is usually kind of the standard we use in statistics, but you can adjust it maybe up to 10% or down to maybe 1% depending on the application. But we pick, so if the stakes aren't that high, we just default to 5%. But if the stakes get really high, like HIV or drinking dirty water, right, things like that, then maybe that's when we start tooling around with the alpha level to suit our needs. All right? Yes?
So you're just gonna pick
Yeah, so I mean, for the sake of this class, I'll typically provide an alpha level for you. You know, I might ask you a question, hey, what seems like a good alpha level? But when you're actually performing a test, typically I'll provide the alpha level for it. Your homework will always provide you the alpha level to perform that. Okay. So we're pretty much out of time though. So tomorrow, this is what we'll do. We'll actually not tomorrow. Monday, we'll actually figure out how to make the cutoffs and do the tests. But it's kind of like confidence intervals. Once you develop the test, it's way easy. It's just following the formulas.